There seems to be an unspoken rule in nature that as long as the sun is shining and the water is liquid, life has a fighting chance. We're used to the idea of Earth being a place of vibrant, sometimes terrifying activity. Usually when we think of prehistoric dangers, our minds go straight to the heavy hitters. We think of the T-Rex prowling through a humid Cretaceous forest, or the megalodon dominating a warm tropical ocean, or even the massive Spinosaurus claimed to be the largest predator to ever walk the land. Even during the last ice age, the one we all know from the movies, we had things like the woolly mammoth and the cave lion, animals that were obviously tough, but they were still living in a world that fundamentally worked. But what if I told you there was a window of time where all of those icons would have stood zero chance? A time when Mother Nature didn't just throw a predator at life, but decided to turn the entire planet into a silent, frozen tomb for 100 million years. This wasn't a mass extinction caused by a single bad day, like the asteroid that ended the dinosaurs, and it wasn't a localized cold snap. This was the Cryogenian Period. The moment Earth essentially broke. It became a cosmic freezer, a blinding white marble where the sun's heat was literally rejected by the surface. Scientists call this Snowball Earth. Now that sounds like a cute name, maybe something you'd find in a winter-themed video game level, but the reality was a planetary-scale death sentence. It was a time when the sun literally failed to keep the world alive, and the Earth became a giant ice cube floating in the dark. Imagine a winter so absolute that it didn't just last for a season, but for a duration that makes the entire existence of humanity look like a heartbeat. So how did the planet turn into a giant ice cube? What happened to the life that was already there? And more importantly, how did the Earth eventually thaw itself out of a permanent death? Let's find out. To understand how the world froze, we have to look at what it looked like before the frost moved in. We're going back about 720 million years, and if you had a map of the world back then, it would look absolutely nothing like the one on your wall today. There was no Africa, no Americas, and definitely no Australia. Instead, there was Rodinia. Imagine taking every piece of land on the planet and smashing it into one giant rocky jigsaw puzzle. And here's the kicker. This supercontinent wasn't spread out across the poles. It was centered almost entirely on the equator. Now, usually the equator is the warmest, most tropical place on the planet. It's where you go to escape the winter. But Rodinia being at the equator was actually the first step in Earth's accidental plan to kill everything. At this point in time, life was pretty much restricted to what I like to call the slime lords, microscopic bacteria, and early multicellular organisms floating in the shallow seas. No brains, no bones, and definitely no cool saber teeth yet. Just pure survival. For millions of years, they were doing just fine, soaking up the sun in a world that was actually quite warm. But beneath the surface, the planet was working with a serious handicap. We call it the young, faint sun paradox. You see, stars actually grow hotter as they age. 700 million years ago, our sun was about 30% dimmer than it is today. If you could see it back then, it would look like a weaker, colder version of the star we know. It was essentially a star running on a low battery. The only reason Earth wasn't a frozen wasteland already was the greenhouse effect. Carbon dioxide was the planet's heavy wool blanket, trapping what little heat the sun provided. But then, Rodinia did something unforgivable. It started to break up. When a supercontinent breaks up, it creates thousands of miles of new coastline. More coastline means more rain. And here is where the chemistry gets hostile. When rain hits volcanic rock, specifically the basalt that made up much of Rodinia, it triggers a chemical reaction called silicate weathering. This isn't just erosion, it's an atmospheric heist. The rock literally eats carbon dioxide out of the air, turns it into a liquid and flushes it into the ocean where it sinks to the bottom. Because Rodinia was sitting right on the equator, the wettest place on Earth, it was essentially a giant carbon scrubbing machine. The planet was pulling its own blanket off in the middle of a cosmic winter. The heat started to escape, the global temperature plummeted, and then we hit the point of no return. In climate science, there is a terrifying concept called the albedo effect. White surfaces like ice reflect about 90% of sunlight back into space. Dark surfaces like the ocean absorb it. As the ice caps started to grow from the poles, they reflected more heat, which made the world colder, which made the ice grow faster. It was a feedback loop of death. Climatologists have calculated that once ice reaches 30 degrees latitude, roughly where Florida or Egypt sits today, the albedo effect becomes unstoppable. The Earth becomes a runaway train of frost. At this point, The ice didn't just crawl, it slammed shut. In a geological blink of an eye, the equator was buried under a sheet of ice. Earth was officially redacted from the solar system's heat map. Imagine the scale of the ice we're talking about. This wasn't a thin crust like you'd find on a local pond. This was a shell of ice 1 to 2 kilometers thick. To put that into perspective, that's taller than 2 Burj Khalifas stacked on top of each other. This ice was heavy enough to crush the continental shelves, pushing the land down into the mantle. The oceans were completely cut off from the atmosphere. No oxygen could get in. No light could reach the depths. The world was effectively a black ball Earth beneath the surface. So how did anything survive? If you were a slime lord living in the shallow ocean, your world just became a tomb. The sun was gone, the oxygen was disappearing. This is where scientists get into a bit of a fight. Some think there were refugium, small pockets of open water near the equator where life could huddle together. But the more hostile and likely answer lies in the deep. While the surface was a silent void, the Earth's core was still screaming. Volcanic vents on the ocean floor became the prehistoric bunkers. Life retreated here, evolving to survive not on sunlight but on chemicals. This is called chemosynthesis. They were living on borrowed time, huddled around the only heaters left in a dead house. But there was another threat, the oxygen crisis. With the ice blocking the air, the oceans became anoxic, or oxygen-starved. If the freeze lasted much longer, life wouldn't just freeze, it would suffocate. But wait, it gets even weirder. There's evidence that life survived in the ice itself. Some bacteria can live inside tiny veins of salt water within glaciers. They essentially paused their lives for millions of years, waiting for the world to wake up. This is survival at its most extreme. No hunting, no growing, just existing. For tens of millions of years, the Earth stayed like this, a silent, white marble floating in space. To an alien observer, Earth would have looked as dead as Jupiter's moon Europa. But the ice had a weakness. It was a prison, but a leaky one. Volcanoes don't care about ice. They're powered by the deep, churning heat of the mantle. Underneath the miles of frost, volcanoes were still erupting. Normally, the carbon dioxide from volcanoes is washed away by rain. But there was no rain. The CO2 started to build up in the atmosphere, higher and higher. For 100 million years, the Earth was bottling up its greenhouse gases. It was like a pressure cooker with the lid taped shut. The CO2 levels reached 300 times what they are today. The atmosphere became thick, heavy and toxic. The blanket was back, and this time it was a heavy-duty electric heater. Slowly, the white Earth started to turn a dirty, soot-covered grey. The ice began to sweat, and when the threshold was finally hit, the ice didn't just melt, it collapsed. The melting didn't happen slowly. It happened with a violence that makes the dinosaur extinction look like a mild inconvenience. The global temperature swung from minus 50 degrees Celsius to plus 50 degrees Celsius in a matter of centuries. Imagine the energy release. The entire world's worth of ice turning into water almost overnight. This created the greatest storm in Earth's history. We're talking about hypercyclones with 500-mile-per-hour winds that lasted for thousands of years. The rain that followed was acidic, eating the mountains and flushing massive amounts of nutrients into the sea. The oceans were no longer a freezer. They were a nutrient-rich soup, and life didn't just survive. It exploded. This led to the Avalon explosion, the moment life finally got big. For the first time, organisms grew muscles, shells, and nervous systems. We are the children of the frost. If Earth hadn't tried to kill everything with a 100-million-year winter, we might still be nothing more than green film on a rock. But let's step back for a second and really think about the daily reality of that snowball world. If you were standing on the surface of Rodinia 700 million years ago, you wouldn't just be cold. You would be in a world where the very concept of weather had essentially died. Without an open ocean to drive the water cycle, there were no clouds like we know them. The sky would have been a perpetually hazy pale blue, filled with fine ice crystals that caught the dim sunlight in eerie halos. The wind, however, would have been your constant enemy. On a planet covered in ice, there is no friction from forests or mountains to slow the air down. The wind would have roared across the continents at speeds that would make a modern hurricane look like a light breeze. This wind would carve the ice into jagged razor-sharp formations called penitentes. blades of ice that can grow to be the size of a house. It would be a world of absolute crushing silence, punctuated only by the occasional boom of a glacier cracking, a sound that would carry for hundreds of miles across the frozen wasteland. Now let's look at the winners and losers of this event. In true hostile Earth fashion, the winners weren't the strongest or the biggest, they were the most stubborn. The cyanobacteria, those tiny green machines that have been around since the beginning of time, took the biggest hit but made the biggest comeback. During the freeze, they were reduced to tiny populations huddling in the slush. But they were overpowered in one specific way. They could wait. When the melt finally happened, these bacteria didn't just return, they went into a global feeding frenzy. The flash melt had washed billions of tons of phosphorus and nitrogen into the sea. It was like dumping a mountain of fertilizer into a fish tank. The cyanobacteria bloomed on a scale we haven't seen since. They pumped so much oxygen into the water and the air that they essentially terraformed the planet. This is the moment everything changed. Before the snowball, life was low energy. There wasn't enough oxygen to build complex bodies. But after the snowball, the oxygen bloom gave life the power-up it needed. Suddenly it was optimal to be big. It was optimal to have a digestive system. We see the first animals, creatures like Dickinsonia and Kimberella, strange quilted things that scuttled across the new seafloors. They were the pioneers of a world that was finally, after 100 million years, hospitable again. But why did it take 100 million years? That's the part that really messes with your head. Most extinctions, like the asteroid that killed the dinosaurs, happen in a geological heartbeat. Even the Great Dying, as bad as it was, only lasted for a few 100,000 years. But the Cryogenian was a stalemate. It was a war between the sun, the ice, and the volcanoes that lasted longer than the entire age of mammals. It tells us something chilling about our planet. It doesn't always bounce back. Sometimes Earth gets stuck in a system error. We only escaped because of a series of geological flukes. If the volcanoes had been slightly less active, or if Rodinia had broken up differently, Earth would have ended up like Mars or Europa, a dead white marble lost in the dark. As we look at our world today, it's easy to feel like we're in control. We worry about a few degrees of warming, and we should, but we often forget that the Earth is a hostile machine that has swings we can barely comprehend. We live in an interglacial period, a tiny window of warmth in a history that is defined by ice. The cycle of supercontinents hasn't stopped. In a few 100 million years, the landmasses will smash together again to form Pangaea Ultima. The silicate weathering cycle will kick back into gear. The CO2 will be scrubbed from the sky. And the frost, which has been waiting at the poles for millions of years, will start its long crawl back to the equator. Think about the sheer improbability of your own existence for a second. Every single one of your ancestors, every fish, every worm, every single-celled slime lord had to survive that 100 million year winter. They had to huddle around volcanic vents in a pitch-black ocean, starving and gasping for oxygen, just so you could be here today to watch a video about it. We aren't just the children of the stars, we are the children of the frost. We are the descendants of the ultimate survivors. If you set foot on that frozen earth, the first thing you'd notice is the silence. No wind in the trees, because there were no trees. No sound of birds, because there were no birds. Just the absolute crushing quiet of a world that has stopped breathing. The air would be incredibly thin and dry, making every breath feel like a struggle. The sky would be a pale, hazy blue, with a sun that looked more like a bright, cold star than a source of life. You'd be standing on a surface that was harder than steel. The ice wouldn't be white and fluffy. It would be blue and jagged, carved by millions of years of wind into strange alien shapes. And if you looked down through a crack in that ice, you'd see nothing but a black abyss. That is the world we come from. That is the heritage of every living thing on this planet. We are built from the pieces of life that refuse to die in the dark. We are the descendants of the organisms that looked at 100 million year winter and decided to wait it out. That kind of resilience is baked into our DNA. It's why life has survived 5 mass extinctions and every disaster the universe has thrown at us. But as we sit in our climate-controlled rooms and look at the world through our screens, we forget how quickly that can change. Earth doesn't owe us a stable climate. It doesn't owe us a warm sun. It is a hostile, shifting, violent machine that we just happen to be riding for a few thousand years. The Cryogenian is proof of that. It is a reminder that the peace we see in nature is just a temporary truce between catastrophes. When you look at the rock layers from this period, you see a jagged line. Below it, ancient, twisted rock. Above it, smooth layers of limestone. That line is the 100 million year winter. It is the physical scar left by the ice. And just above that scar, we see the first complex fossils. Life didn't just crawl back, it sprinted. The ancestors of everything from jellyfish to trilobites suddenly appeared, as if they had been waiting in the wings for the stage lights to come back on. What's even more mind-blowing is that this event might be the reason you have a brain at all. Some evolutionary biologists think the extreme stress of Snowball Earth forced life to become multicellular. When you're huddling in a tiny pocket of water, sharing resources becomes a survival strategy. You either cooperate or you die. The very first societies on Earth weren't made of people or even animals. They were clusters of cells trying to survive the freezer. It's also worth noting that Snowball Earth wasn't just one single event. Most scientists think there were actually two massive glaciations, the Sturtian and the Marinoan. Imagine surviving the first 50 million year winter, finally seeing the sun again, and then, just as you're getting comfortable, the ice comes back for round two. That is the level of hostility we're talking about. Earth wasn't just having a bad day, it was having a bad epoch. But as the millions of years ticked by, the balance slowly shifted. Each volcanic eruption was a tiny hammer blow against the ice. Each molecule of CO2 was a tiny piece of insulation added to the atmosphere. It took an almost incomprehensible amount of time, but eventually the hammer won. The ice cracked, the light came back, and the world that emerged was something entirely new. The scale of the thaw was equally nightmarish. As the ice melted, it didn't just turn into nice, gentle rivers, it was a planetary-scale flood. The fresh water pouring into the salty oceans would have changed the buoyancy and chemistry of the water column, creating massive dead zones before the oxygen bloom could take over. It was a transition from one kind of hell to another, but life, as it always does, found a way to bridge the gap. In the end, the Cryogenian reminds us that the Earth is not a static place. It is a giant spinning laboratory of chaos. We focus on the big names of paleontology because they are easy to see, the skeletons of giants that look like us or the predators we fear. But the real story of our survival was written by the nameless microscopic pioneers who braved the dark and the cold for 100 million years. They are the real heroes of the hostile Earth. So what's the final verdict on the 100 million year winter? It was the ultimate test. It was a planetary filter that wiped out the weak and forced the survivors to innovate. Without that freeze, life might have stayed as slime forever. The hostility of the Earth is exactly what forged the complexity of our bodies. Next time you step out into a cold morning and feel that bite in the air, don't just reach for your coat. Take a second to remember the Cryogenian. Remember the world where the sun was a stranger and the ice was king. We survived the longest winter in history once. But on a planet as violent and unpredictable as this one, you have to wonder, are we just in a very long half-time? Earth has proven it can press the reset button whenever it wants. It's done it with fire, it's done it with asteroids, and as the Cryogenian proves, it's more than happy to do it with ice. Thanks for watching this survival log. If you're fascinated by the ways Earth has tried to press the reset button, make sure to subscribe to Hostile Earth. We've got plenty more stories of near annihilation and the stubborn life that survived it. We'll be looking at everything from the giant land crocs that ruled after the dinosaurs to the time the sky literally fell during the Great Dying. Until next time, stay warm, keep an eye on the horizon, and remember, the frost is always patient. It has all the time in the world. See you in the next era.